a template with modern tooling for Three.js using Vite. It's a starter I like to use for my example projects. Let's start in a shell, set your path to where you want your project to be, and execute npm create Vite. Give it a project name. We're going to go with a vanilla framework, and I'll choose TypeScript, but you can do this in JavaScript, just remove the types. Once the scaffolding is complete, cd into your project and install the dependencies. And now we'll launch IntelliJ IDEA at this path. Let's go into the package.json and run the dev script. And actually, instead, let's add the -- open so that Vite automatically opens a browser for us. And here is the starter template. And we're not going to be needing any of this. So let's take a look at what we've got. Starting with the index. The index is going to be loading this main TypeScript file. Let's go into source. Let's look at this file. And we don't need pretty much anything in here. We'll keep the style definition and get rid of everything else. We don't need this counter example, so let's delete that. We don't need this TypeScript SVG, so let's get rid of that. Here in style, we really don't need much of any of this. Let's get rid of everything except for the body definition. And here, the only thing that we really need is the margin 0. Most people would typically add a few things to this, though. For example, for full screen, we might want to add a height of 100 view height. And for overflow, get rid of the scroll bars, we might just clip. Here in our index, we do not need this app div. And at this point, we should be ready to go. We need to install some dependencies, so let's do that now. Let's go to our package.json. We need the 3 package. We need the 3 standard lib package. Because I'm using TypeScript, I'm going to install the types 3 package. And while I'm in here, I'm going to add prettier for code format. Okay, with those complete, we should be ready to go. We start by creating a scene. I'll define a scene, create a new instance of scene. Next up, we're going to need a camera. I'll define a camera as a new instance of perspective camera. Our field of view, I'm going to go with 75. Aspect ratio, we're going to take the window inner width over the window inner height. And for our near, I'm going to go with something very small. Far, we're going to go with a 1000. Lastly, let's set the camera position Z to 5. Now we need to create the renderer. We create a renderer with a new WebGL renderer instance, and I'm going to enable anti-aliasing. We need to set the size of our renderer, which is the window inner width and the window inner height. We can give our renderer a background color if we want. This is optional. I'm going to go just a little bit off of black so that we can see anything that is pitch black in the scene. And there's more than one way that we can apply this renderer to the HTML DOM. The classical way would be to take the built-in DOM element from the renderer and append that to the body by using document body append child renderer DOM element. If you have a canvas of your own, you could alternatively use that canvas. So for example, in the index HTML, we can just define a canvas. And then back here in our main TypeScript file, what we could do is we could reference that canvas. So we'll create a canvas instance. We'll do a document query selector. This is of a type HTML canvas element. And we will just grab the canvas DOM element here. And in our new WebGL renderer constructor, we can pass in a parameter for the canvas. This can be a little tricky because we have to assure the canvas element actually does exist, which we could do with the non-null assertion operator, the exclamation mark. Otherwise, we need to provide some kind of conditional checking, which is a little complicated in a top-level statement like this. I'm simply going to add the built-in DOM renderer to the document body. So let's undo all of this. Let's put this back. In our index HTML, let's undo the canvas here, and we are back in action. You'll note that even after we've defined the renderer and added it to the DOM, we don't see anything, and that's because the renderer loop is not running. The renderer has never executed any render pass. So we're going to create our animation loop. On the renderer, we're going to use the set animation loop, and inside, execute a render of our scene and camera. And here is our scene. The only thing that we're seeing is the clear color. Note that when we resize the window, the renderer does not update. We need to add a resize handler for that. Let's define a resize handler function. On the inside, we will set the camera aspect ratio This is the window inner width over the window inner height. We need to update the camera projection matrix. And finally, update the renderer size using renderer set size. Lastly, we need to add an event listener to the window. This is a resize event, and we'll pass in our resize handler. And now when we resize our window, the renderer updates. So this scene's a little boring. Let's add some example objects in here. We'll start with the classic cube. We'll define some geometry. This will be a box geometry. We need to define a material, and we will go with a mesh standard material. In here, we need to pass in a color, and I will go with a classic green cube. We define our cube as a mesh that takes both the geometry and material that we just created. And finally, we add it to the scene. Note that it's almost impossible to see. Because our clear color is a little bit off, we can see it. It's pitch black in the scene, and that is due to the fact that there is no lighting in the scene. In fact, we could just change the clear color and make it perfectly obvious. There it is. It's pitch black. Let's set that color back and create a light. Add a light to the scene. We're going to define a light, and this is going to be a directional light. We'll pass in a color of white and an intensity of 1. We'll set our light position at a 050 and add it to our scene. And due to the perspective of our scene, still not a whole lot going on in terms of visibility. Let's add some orbit controls. We'll define controls as a new orbit controls. We'll take it from 3 standard lib. And we pass in our camera and the renderer DOM element. And then we need to call an initial update on this. Now using the mouse, we can rotate the scene, and there it is. Let's add some animation to our cube in our renderer's animation loop. Our cube rotation X and Y, we will add 0.01. And now we can see it rotating. Let's further enhance this just a little bit more. Let's add a plane. Let's create some ground geometry. This will be a plane geometry. And I'll give it a width and height of 10. We'll need a ground material, which I will use a mesh standard material again. I'll give these RGB channels 80 for a gray color. We define our ground as a new mesh that takes our ground geometry and our ground material. Finally, add it to the scene. And when you do, note that the plane is actually vertical. It's hard to see. We'll need to apply a rotation around the x-axis, taking negative math pi over 2. There it is, but let's update its position on the z-axis. Perfect. Lastly, let's make this scene a little bit more realistic by adding some shadows. We start on the renderer instance by enabling a shadow map. Renderer shadow map enabled equals true. Our cube will cast shadows. We set that property to true. Our ground will receive shadows. We set that to true. Our light will cast shadows. We set that to true. Maybe we'll go one step further. For a bit of shine, we can reduce the roughness and increase the metalness, and we get a nice reflective surface. And there we go, a simple, easy setup with live reload. It's incredibly fast, whether we're developing in a single file or whether we're developing a large project with many files across multiple directories.